Welcome to Study Life. In this section on mechanical properties of solids, we are going to learn about Young's modulus. Where is this story of Young's modulus coming from? Robert Hooke in the year 1861 published his Hooke's law, wherein he stated that stress is directly proportional to strain. If I talk about it, I am very much clear that there has to be a constant of proportionality, and that constant was later named as modulus of elasticity. For certain conditions where linear options are available, like here, where I have a wire suspended from a rigid support. This happens to be my rigid support, this happens to be wire, and there's a load of weight kept over here. For such scenarios, the type of modulus of elasticity that work with me is called as Young's modulus. So basically, Young's modulus is for things that are linear in the structure, generally about a wire. Let's work with this wire. Let's understand how this story works. Let me just assume, since it's a rigid support, I'll just draw lines that say that this happens to be my rigid support, a support that does not move. It's very fixed. From here, I have a wire that is kept. Okay? So let's assume that the length of this wire, let's say, is capital L. What is the length of this wire, bacho? Let's say it is capital L. And there's a tiny weight that is kept over here in order to extend this wire. Let's assume that the weight of this wire is mg. Weight is something that is always acting vertically downwards. Also, let's assume that there is some extension observed due to this weight. Due to this weight, there is some extension observed, and let's call this extension as small l. Let's call this extension as small l. Let's start working with this story now. In this case, if I decide to calculate my value for longitudinal stress, what is longitudinal stress? As normal, longitudinal stress is force acting per unit area. And in this case, the force is nothing but the weight that is acting on this wire. Weight is mg, therefore my force is also equal to mg. If I talk about a wire looks like this. When I zoom it like 10 times, I see that this area over here is nothing but a circle. Therefore, the area for this wire has to be the area of the circle, that is pi r square. Mg upon pi r square is my expression for longitudinal stress. Let's now focus on longitudinal strain. What is longitudinal strain? Longitudinal strain. Strain is the change in dimension divided by the original dimension. In here, the change in dimension is small l, whereas the original dimension is capital L, correct? So the extension divided by the original length is my expression for longitudinal strain. If I am very correct, modulus of elasticity is stress divided by strain. Therefore, if I ever want to calculate the value for Young's modulus, let's just write it as eta or y, is basically longitudinal stress divided by longitudinal strain. Longitudinal stress is mg divided by pi r square. Mg divided by pi r square. Longitudinal strain is extension divided by the original length. All I have to do is divide them. So when I am dividing, the upper one has to work with the lower one, whereas the ones in the middle, they kind of combine with each other. Therefore, the expression turns out as mg, the original length, divided by pi r square times the extension is my expression for Young's modulus. Young's modulus, since Young's modulus is a constant for every wire, since it is an inherent property, it is a type of modulus. Therefore, the units and the dimensions of all the modulus of elasticity applies to Young's modulus as well. That means the unit for Young's modulus is Newton per meter square in SI system. If it is CGS system, it is Dian per centimeter square in SI system. Okay. If I talk about dimension, the dimensions for all of them is same. It's m1 l minus 1 t minus 2. As I said, Young's modulus is an inherent property of the wire. So if I take a small section of this wire, the Young's modulus is going to stay the same. If I take a large chunk of this wire, again the Young's modulus is going to stay the same. Two wires of the same material will have same Young's modulus irrespective of the length, the area and every other parameter. So I suppose you now know a lot about Young's modulus. With that in mind, I'll conclude today's session. Meet you in our next session. Until then, stay tuned with Study Life and keep learning. Thank you.